Hello again, everyone. Welcome back to Streaming School. We are joined by the better of the two mics on screen today. How are you doing, Mike?
You too kind, sir. Yeah, I'm all good. I'm all good.
And obviously, we're here with Niche as well. And what have you been up to, Mike?
Today, I did my Navy SEALs hit workout this morning, so I'm feeling good, feeling fresh.
So does that involve you sitting in the ocean overnight for hours? Is that how it works?
No, it just involved me on my drive. Nothing exciting like that.
Well, mate, some may say exciting, mate. Some might say torture. Depends, doesn't it?
That's it.
Nish, have you been doing anything of that nature recently?
No, I probably should be.
This is it, isn't it? Have you seen the? It's that whole. There was a joke, was there recently? The whole unlimited exercise, and some people saying that I'm lucky if I do. You know, the only exercise I have is to the fridge and back. So unlimited is like
pretty much.
Oh, yeah.
That's why I've got to do this HIIT training.
Tell me about it. I've literally just run downstairs to sneak a chocolate biscuit up. That's it's all right. So anyway, Mike, what can everyone at Streaming School expect today in their science session?
We're looking at nuclear decay or radioactive decay and half-life.
Nice, thank you. Are you not talking about the computer game, are we here?
This is not. No, you're at the wrong place if you want Half-Life, the Xbox game walkthrough. You're in the wrong place for that.
You're getting just as many views as an Xbox walkthrough. Don't you worry about that.
Of course I would, mate. Of course.
Well, I'll leave it to you. So thank you. I'm really looking forward to it, Mike.
Cheers. Take care. So this lesson, guys, as you've probably just heard, we're going to be looking at the different types of radioactive decay, and I'm really hoping that the time allows me to also cover something called half-life. So let's just start off first of all with our radioactive decay, and I want to take your mind back to chemistry, where we looked at chemical symbols, okay? Symbol. Where A represents the atomic mass number, and just remember that the atomic mass number is the number of protons and the number of neutrons. And Z is the atomic number. Okay? The atomic number basically means the number of protons. Okay? And we're going to use all of this to actually understand radioactive decay. Because if you remember from our last physics lesson, we was learning all about alpha, we was learning about beta, and we learned about gamma radiation. We were learning about the properties of those three radiations, and today's lesson, what we're going to see is what effect these different radiations have on the nucleus. Okay, so let's just start off with alpha radiation first. Alpha radiation, if you remember, it's given a symbol kind of like a fish like this, and alpha radiation is made up of 2 protons and 2 neutrons. Okay? So we can represent an alpha particle like this, because remember that this top number here is what we call the atomic mass number. So this is the number of protons and neutrons. So we've got 2 protons, 2 neutrons. This is why the top number is 4, and the bottom number is the atomic number, or the number of protons. So let's just observe what happens when a nucleus does alpha decay. Okay. For example, let's say I've got a carbon atom. Okay. And let's say that my carbon atom is radioactive. Now, my carbon atom that's radioactive is going to emit an alpha particle. It's going to give off alpha radiation like that. So that means that this carbon atom here has lost 2 protons and 2 neutrons. Now, what you would be expected to do in your exam is you should be able to, with this information, you should be able to work out the new element that has been formed. And there's a very easy way to do that. All we do is 12 take away 4, and that would give us 8. So our new element has a mass number of 8, and we do 6 take away 2. So we know that our new element has an atomic number of 4. Now, what you'd be expected to do is look in the periodic table and be able to identify what this element is. Luckily for me, I've got a periodic table right next to me, as always. So this new element is beryllium. Now, the chemists out there may be moaning that, look, this number at the top here doesn't match the number that's in the periodic table. And for the chemists that are out there, you guys should remember that, I'm just changing colors here. You guys should remember that it's the atomic number, remember the number at the bottom, that determines the element that it is. So this would actually be an isotope of beryllium, because it has the same number of protons, it just has a different number of neutrons. Just to embed that, I'm going to do 2 more, or I'll write 2 more on the screen, and I'll give you guys a chance to see if you can work them out. So let's say we've got fluorine. Fluorine is 19 and 9. And let's say fluorine undergoes alpha decay. See if you can work out the 2 numbers that are missing, and then see if you can identify the element that this corresponds to. So we'll do that one as an example, and I'll also give you a bit too early in the morning to be testing my periodic table. Let's do sodium, and again, sodium is doing alpha decay. And again, guys, I'll just give you just a few seconds just to see if you can work out what are the missing mass numbers, what are the missing atomic numbers, and see if you can work out the element that it corresponds to. So hopefully what you guys have done, and I'll just change color so it all stands out. Hopefully what you guys have done is you remember that we do 19 take away 4, which gives us 15. And then we do 9 take away 2, which gives us 7. Now remember, it's the 7 as the, this is our atomic number. It's the atomic number that determines the element. So this would actually be an isotope of nitrogen. So, from alpha decay, fluorine has turned into nitrogen. And then if we look at sodium, again, we do 23 take away 4, and that's 19. And then we do 11 take away 2, and that gives us 9. Oh, look at that. I didn't even do that on purpose. We've turned sodium into fluorine. There you go. So what we've done is through alpha decay, we've actually produced new elements, and you would be expected to be able to predict the new elements that are produced, the ones that I've done in red. Okay, so that's alpha decay. That's alpha decay. Let's jump over to beta decay. Okay, let's jump over to beta decay. And what I'll do is I'll put a nice line through alpha because we've now done that one. So let's go to beta decay. Okay, beta has this symbol. It's like a B with kind of like its elongated back like that, and that's the symbol for beta decay. Beta decay occurs when a neutron turns into a proton and electron. Okay, and it's this electron here that's been produced. The proton stays in the nucleus, but this electron here, this electron is fired out at a high speed. So it's this electron here that's been fired out at this high speed. This electron is our beta radiation. Okay, and if anyone is interested in A-level physics, in A-level physics you will understand or learn about how a neutron turns into a proton. Very interesting stuff. So I'm just going to zoom out a touch. So let's take a look at what happens to a nucleus during beta decay. Okay, again, I'm going to stick with my example of carbon. Okay, carbon 12, and my carbon 12 atom undergoes beta decay. Now I'm going to put my beta particle over here. Okay, now remember, because a beta particle is just an electron, is -1 and the mass is 0. All right, this is going way back now to our first lesson in chemistry, when we learned that the charge of an electron is -1 and the mass is 0. And this is, this is where it all kind of ties together, where chemistry meets physics and etc. So let's figure out from this then, guys, what is the new element produced? Well, this is quite easy, because 12 take away 0 is still 12. So you should notice that the mass number has not changed. Look at that. The mass number has stayed the same. The mass of this new element does not change. And then 6 minus -1, well, when you do 6 minus -1, that now becomes a positive. So it actually becomes 6 plus 1, because when you've got two negatives, it becomes a positive. So this then becomes 7. If we look at our periodic table, you will see that this is an isotope of nitrogen. So once again, guys, what I will do is give you some examples, because, it's all good listening to me babbling on, but let's actually give you some practice solving these nuclear decay equations. So what I shall do is I'll give you 2 again, just to have a go at. I'll give you aluminium. Aluminium has got 13 protons and a mass number of 27. And again, look, remember, it's a B. Oops. See, even Even I made a mistake there. Put it at the top. So 0 minus 1. And what I want you guys to do, see if you can tell me what will this new element be formed. And for B, let's do calcium. And again, I will put a beta particle just there. See if you guys can work out what the new element formed would be. So I'm hoping, guys, that you kind of followed the method that we did before. 27 take away 0 gives us 27, and 13 minus 1 would give you 14. And if you look in the periodic table, this is actually an isotope of silicon. So aluminium has decayed into silicon. And then if we apply the same principle to our final one, calcium over here, remember 40 take away 0 still gives us 40, and 20 minus 1 would give us 21. And again, guys, if you look in the periodic table, this will give you an isotope of scandium, which has the symbol Sc, scandium. Now, you'll be happy to know, you'll be quite happy, and oh, just before I forget, we can cross out beta now because we've done beta decay as well. So in 15 minutes, I've taught you alpha decay and I've taught you beta decay. We're going to finish with gamma. Unfortunately, guys, you'll have to stay tuned for next week when I do half-life because I've run out of time. I get a bit too excited with physics. So with gamma radiation, it's important to realize, right, that gamma is just an electromagnetic wave. Okay? Gamma is not made of any particles, it's just a wave of energy. So the good thing for you guys to remember here is that when a nucleus undergoes gamma decay, there is actually no change to the proton or neutron number. And you know that's a nice one to remember, because if it's gamma decay, there's no change. Just remember, if there's alpha decay, you lose a mass number of 4 and a proton number of 2. If it's beta decay, the mass number stays the same, but the proton number goes up by 1. And that's my quick tips. There you go.
Thank you, Mark.
Yeah, not a problem.
Yeah, really useful.
So I will hold half-life for next week, so stay tuned. There's a bit of suspense there for everybody.
I'm looking forward to it. It's like a teaser trailer you've just given us.
There you go. I just gave you a little teaser. Can't give it all away, just a little teaser.
Thank you. And what's the plan for the rest of the day, Mike?
I'm actually playing a YouTube video now, so I'm going to blow some potassium, sodium, and lithium up in my garden. So, yeah, just going to go plan that and enjoy the day.
Well, amazing. Well, obviously, make sure you're safe. And if you're not here with us for your next session, then we know exactly what's happened, don't we?
Yes. I did it for a good cause.
All right, Mike. Thank you so much.
See you in a bit.
Bye, guys. And obviously, up next, as you can begin to see, we'll have some Spanish. So we are looking forward to that in a couple of minutes' time. Thank you, guys.
Thanks.